Hi everybody, this is the second video of my hash table series, and this particular one is about collision resolution. So collision resolution is effectively the thing that you do when collisions occur. So when collisions occur, this is what you do, okay? So it's not, we cannot avoid collisions. So we have to have a way to actually handle those moments when a collision does happen. We don't want to have it so that we don't know what's going to do, what we're going to do when a collision does occur. So collision resolution is all about what happens when two records, two different keys, want to occupy exactly the same space, okay, exactly the same index. And how we resolve it, there are actually two general ideas of how this can be resolved. And they can be sort of described, the two methodologies can be described as either closed addressing or open addressing. So this video is going to talk about each of these sort of in general, and then there will be a couple of other videos that talks about each of the techniques separately. Okay, so let's start with closed addressing. Closed addressing is a very simple idea. So closed addressing means this. Uh, the hash index provided by hash function always leads to the correct index in the array. Okay, so we use the hash index exactly as it is. We don't try to say, oh, this place already has something, we'll go to the next one or something like that. We'll change where we mean by putting it. We actually say, well, if you say it's going to go into index 5, we will put it into index 5. Now, of course, what happens if there's more than one thing that wants to go into index 5? Well, what we do is we allow multiple records to be stored at the same index. Okay. Um, After hashing to the array location, we perform a search through the records at that index. So in general, what we do is we say, okay, instead of just saying we can only have one record here, we're going to have a few. Okay, now exactly how many that is, or if there's a restriction at all, depends on exactly the way that you do closed addressing. But the idea is simply this. At every single location, we allow more than one record to be stored. You use the hash index to get to this collection of records, and then you do a search through them. Now, know that this particular method, you're not trying to have a giant collection everywhere. Okay, so this is really important and a really easy mistake to make. Your hash function ideally provides a separate hash index for every single record. So if you plan to store 50,000 records in your table, don't make your table 10,000 elements big. You guarantee that something is going to collide then. If you think you're going to have 50,000 records, you should make an array that is 50,000 elements big, right? Minimum. Now, if there is a collision, you can store more than one thing at a location. In other words, there will actually be empty spots within your table. That's okay. The idea of storing more than one thing is not so that you can have a whole bunch of these giant pots of records, because each of those requires a separate search. And the bigger these pots grow, the more that will matter. So you're not trying to have like a huge, giant, separate structure of these things. What you want is ideally you go to the thing, there was one record there, that's the one you want. But if there happens to be more than one, then you do a simple search and you find it. That's the idea for all closed addressing systems. So, so this is how they work. We're going to talk about exactly how this is implemented um, in the next video, but this is sort of the general overview. Okay, so that's closed addressing. Take a hash index, run it through a hash function, let it go to a certain position, and that's it. Okay? And at that location, more than one record can exist. Now, next thing, let's take a look at what happens with open addressing. Okay? The hash function, so the hash index suggests the best place to put a record. So this is the thing that that is about open addressing. We don't actually take the hash index exactly as it is. Okay. So the hash, we calculate a hash index, and let's say we look there and it's available. Great, we put it in, right? Now, if the hash index is, if what the hash index says is already occupied, so we're doing an insertion, we look there and, oh, there's already a record there, what do we do? Well, if the position that we want is unavailable, what we do is we look for the next available spot. And there's a few different definitions of what next means. Okay, so there's different ways of doing open addressing as well. So the simplest is called linear probing, and what you do is you say, oh, this element, let's say 5, is occupied. So what do? I look at 6. Is it occupied? If it is, go to the next one. 7, is it occupied? And move along until you get to the first available spot. And that's pretty much how open addressing works. So you begin by saying, we're going to always look for or try to put something in where the hash index says. But if that fails, we're going to look at the next spot, and then the next spot, and then the next spot, and go from there. Okay? Now, implementation-wise, there's more details than that, but I want to just give you a context of how these work. Close addressing, wherever the hash index says to go, that's where you go there first. If there happens, but at that location, there might be more than one thing, so you have to search through a second collection in order to find the exact record that you want. With open addressing, the hash index tells you this is where it's supposed to go, but it might not be there. If it's not there, go to the next spot, the next spot, the next spot, and so on until you actually get to the right position. So we're going to take a look at these separately in turn in the next couple of videos, okay? That's it for now. Bye-bye.